Let's start this video by looking at a soccer player kicking a ball, and let's talk about energy transformations again. So when a soccer player kicks a ball, they're using kinetic energy from their leg, so their foot is moving, and as their foot hits the ball, they're transferring that kinetic energy to the ball, and the ball moves off through the air or along the ground. So we started off with kinetic energy of the foot, and we ended up with kinetic energy of the ball. But what we've actually discovered is that not all of that kinetic energy from the player's foot gets transferred to the ball. And for one thing, we know that there's a sound as you kick a ball. So sound energy is being transformed as well. Some of the kinetic energy from the foot is being transformed into sound energy. And also, right where the foot touches the ball, there's a little bit of heat energy produced as well. Whenever two objects touch or move past each other, there's a transformation of heat energy too. So what happens is, whenever there's a transformation, not all the energy goes where we want it to. Because the soccer player wants all of their kinetic energy to transfer to the ball, but some of it is lost as sound and heat. So we can say that not all transformations go where we want them. Where we want. And another way of saying that is that processes are inefficient. Processes are inefficient, and some energy is wasted, like sound and heat in this example. Waste energy. The best way of looking at energy efficiency is to use a flow diagram again. So for our soccer player, we had kinetic energy of his foot, about to kick the ball, and then it was transferred to kinetic energy of the ball. But as we saw, some of that energy is lost as heat and sound, and that was our waste energy. Heat and sound. And what we can do is start calculating how much of that energy is lost as waste and how much gets transferred to where we wanted it to go. And we can do this by saying that 100% of the energy is at the start. And in this example, let's just make up some numbers. Maybe 75% of the energy gets transferred to the ball, and 25% was lost as heat and sound. So the amount of energy that we transferred or transformed to where we wanted it, that's the efficiency. So the efficiency of kicking a soccer ball here was 75%. Here's another example, and we'll look at cars, and in particular petrol cars, because petrol cars are very inefficient. So we start with the chemical energy that's in petrol, but a car engine or a petrol engine we know is really bad at converting that energy into actually moving the car along. It's not efficient at all, and there's a lot of waste energy. So let's draw a flow diagram again. we start with the chemical energy in the fuel. And we're transforming that to kinetic energy of the car to make it move. But what we know about petrol engines is that they lose 75% of the energy as heat and sound, which is the main way that energy is lost. So 75% of our 100% is wasted, and only 25% of the energy is actually able to be used to move the car along. So we can call a car engine 25% efficient. One more example that we'll look at is to do with light bulbs, because energy efficiency is really important in everyday life. Energy efficiency is important. And there are quite a few reasons for this. So here, if you're deciding what type of globe to put into your house, we have old-fashioned halogen globes, and we have more modern LED globes. And looking at these energy flow diagrams, we can see a halogen starts with 100 joules of energy going in, of electrical energy. 90% is lost, and only 10% becomes light energy. So a halogen globe is only 10% efficient. Whereas an LED, we have out of 100 joules of electrical energy that goes in, 25 joules are lost, which means 75 joules gets converted to light energy, which is the job of a light bulb. So LED lights are 75% efficient. And the reason we want efficient appliances at home and efficient vehicles is for a few reasons. One of them is because it saves money. If we have an efficient light bulb, we're not wasting money paying for electricity. And if we have an efficient car, we're not wasting money on fuel. And for petrol engines and things that create carbon dioxide, we're reducing greenhouse gas emissions. Reducing greenhouse gases, which is really important for reducing climate change, as we know. And also think about all the extra heat that's lost whenever we have waste heat. Often, and particularly in summer, we don't want things creating lots of extra heat, especially if it's in your car or in your house. So buying and making energy efficient machines reduces waste heat as well.